Okay, let's take a look at Introduction to Functions. This is your section 4.5, considered new material. Alright, so let's look at this question here. Is the relation a function? So our relation here is a set of 4 ordered pairs. And how do we tell if it's a function? So we talked in class about the definition of a function says that all input values, or x values, go with no more than one y value. So a way that we can look at ordered pairs is to see, does any x value repeat? If it repeats, it goes with more than one y value. So we see here 2, -1, -7, 6. No x values repeat, so it fits the definition of a function. Is it a function? Yes. How do we name the domain of this function? Well, the domain are all the first values, or the input values, so our set picks up the numbers from the x values, 2, -1, -7, and 6. What is the range? The range is the set of outputs, or the y values. So how do we name the range? It's the set of all the y values, 7, -9, -5, and 0. Right? Is this relation a function? Remember the definition of a function. So remember, in this form we're looking for any repeat x's. 2, 8, 1, 4, 2, 5, 7, 6, and I notice that 2 goes with 8 and 2 goes with 5, so it fails the definition of a function because the function says each input can go with no more than one output. So 2 goes with 8 and 2 goes with 5, or we see repeat 2's in the x values. That says this is not a function. It's a relation which is not a function, just by the definition. Can we still name the domain and range? Yes, we can. The domain is made up of the x values 2, 1. We won't repeat the 2, we already used it, and 7. And the range is made up of the y values 8, 4, 5, and 6. Alright, now we're going to look at mapping. Okay, does mapping represent a function? Alright, so is this relation a function? So here we have input values, output values. So let's see, 4 goes with 5, 7 goes with 13, and 12 goes with 13. So 4 only has one output, 7 only has one output, 12 only has one output. 7 and 12 happen to have the same output, but they each only have one output. So that fits the definition of a function. Is this relation a function? Yes. Okay, what's the domain? It's easy to see in mapping form. The domain is the set of 4, 7, and 12. And what about the range? It's also easy to see. It's the set of 5 and 13. Alright, let's look at this one. Is this relation a function? Remember, each input can only go with one output. So let's see, 17 goes with 19, 17 goes with 20. That ruins it right there, doesn't it? Because 17 goes with 19 and 20, and it should only go with no more than one output. So we say right at that point, it is not a function, but we can still name the domain and range. So the domain is easy to see, the values 17 and 18, and the range is also easy to see, 19, 20, and 21. Okay. Alright, let's take a look. Does the graph represent a function? So I've got to bring in a picture of a graph here. So for the first one, I'm going to use this picture of a graph right here. Does this graph represent a function? Okay, so what we're testing, remember, each input can go with only one output. So our x values are our input. Anytime we find an x, does it ever have the same y value? Well, remember the easy way to run that test is the vertical line test. So we can see that we can drop a vertical line many places on this graph, and no vertical line ever touches the graph more than one place. Okay? If it touches the graph more than one place, it fails. If it doesn't touch the graph more than one place, it passes. So we say, does this graph represent a function? Yes, it does. All right. Now, we're using numbers all over the x and y axis for the domain and range for these points. So how do we name this point? Well, we have to notice the domain is the set of x values, and as this graph continues to grow downward, it continues to grow wider and wider. So it would eventually use up all values on the x-axis. So we say the domain here is the infinity interval. But the range won't use up all values of the y-axis. We're going to read it negative to positive. So it is continuing down here. So it would start in negative infinity, but as we go upward, we don't see any y values after this right here, do we? It stops at the y value 4, exactly 4. So our range opens with infinity, but it closes with exactly 4. All right, let's take a look at another graph. We're going to take a look at this graph right here, and this is our x-axis, and this is our y-axis. Okay, so this one looks like the other one turned on its side. So we're going to see, does this pass the vertical line test? Does this graph pass the vertical line test? No. Okay, we can see that this x value, 25, has an output here and here. Okay, and we can see lots of other places. So a vertical line touches twice here, it touches twice here. Lots of vertical lines there, so we can tell by that graph, fails the vertical line test, it is not a function. So the answer, does the graph represent a function? No. Can we still name the domain and range? Sure. Alright, so how much of the x-axis is needed to show values here? Or can we find the function for these values of x? No, they start with these values of x, don't they? The graph starts with these values of x. So where does that pick up? Let's see, what are our markings here? This is 25, 50, 75, so 5, 10, 15, 20, 25. These go by 5s, so that would be the number 10 on the x-axis. So the number 10 is our starter, exactly 10. And then it continues. Okay, we can see that the x values continue. Now this is the end of our graph, but remember this arrow says it keeps going, and so that graph keeps going as well to infinity. The range. Alright, now let's look at the range here. As the graph continues off to the right, it's also getting taller, or it's getting wider in the vertical direction, isn't it? It's getting wider and wider, or taller and taller. So it's going to eventually use up all values of y. So, you know, here we've got this value, here we've got this value, all along here we've got y values, and we're going to keep using them all up. So that means that the range, or the set of all y values, is the infinity interval.